Hi, everybody. All right, so today we'll be talking about ML, machine learning for systems and systems for machine learning. So in this 5-minute talk, I will call machine learning what many people may call also AI or generative AI. In some sense, generative AI is a form of machine learning. So when I talk about machine learning, you can replace it with AI or generative AI if you prefer, but I will use machine learning in this talk. Right, so this is a topic that I think it's slightly interesting for me because the community, the Postgres community, has been focusing a lot about on PG Vector and a way to support the development of AI applications. And this talk shows that there are two directions to this: machine learning for systems, but also systems for machine learning. So what do I mean by that? This is kind of the definition, and every time I read this, I feel it's a little bit of a tongue twister. So I will skip this and I will just go on the first one, which is systems for machine learning, okay? So the focus here is to build and optimize the computer systems that are necessary to support the training and deployment of machine learning models. So this is all about creating frameworks that allow us to both efficiently and be able to both efficiently and scale as well the machine learning models, right? So some examples here are, for example, the development of hardware accelerators, and everybody knows GPUs, of course, from NVIDIA and ARM and other hardware manufacturers, but also TPUs, for example, tensor processing units from Google and so on. And another example is in terms of software frameworks and tools for managing machine learning pipelines. And here an example that was extremely popular, and it still is, but a few years ago we got this massive productivity boost in terms of building machine learning pipelines that comes from things like TensorFlow. TF stands for TensorFlow. There is also Torch, PyTorch, and all these other Caffe and other frameworks like that. So we often don't really think about how useful those things were to get to where we are in terms of machine learning state of the art. And then there is things like PG Vector, where this is systems for data management and for machine learning, and PG Vector is certainly in that space. Okay, so the goal of these systems for machine learning is to really enable faster and more efficient, more scalable machine learning by basically providing this kind of system level support, right? This is systems or computer systems for machine learning, and computer system is used as a general term for software frameworks, hardware frameworks, data management frameworks, and so on. And the community here is spending a lot of time on this, and I would like also perhaps to promote the other side of this, right? And the other side is machine learning for systems. And what we mean by this is that the idea of using machine learning techniques to improve the design, operation, and optimization of computer systems. You see that here we're going in the other direction, right? Here we're using machine learning to improve systems. The other one was the other way around. And here, the examples that I bring here is, for example, if you look at network traffic routing optimization. We worked on a project, research project called Homunculus a few years ago. It was published in one of the computer systems conferences called Homunculus. You can find on Google Scholar. And this is exactly the type of things that we can do. We can change data plane to basically optimize at the speed of light through machine learning models to optimize how these packets are managed, right? Another example is compiler optimization. So compilers come equipped with a lot of different parameters, and those parameters can affect the way the code is generated, both in terms of quality of code, size of code, and also the speed of the code generated, right? And this is another work that we did at Stanford called BACO, that does exactly that. And the reason why I'm here today is that we do also work on this topic in the Postgres area, and this is about optimizing database management through machine learning, and this is what we call DBTune here. So machine learning for systems is really this idea of replacing and enhancing traditional, often manual or heuristic based. So these are processes that are usually manual or heuristic based for system design with more adaptive and efficient machine learning-driven solutions, okay? So you have a process that's almost entirely manual or based on some rules, this equal this, do that, and then you write a long list of rules like this, transforming that into a system that can learn from data and then act and help on the design of the system, okay? So I'm happy to talk more about these topics. Catch me on the hall if you want to talk more. But I'm really interested in this type of direction of machine learning applied to systems. So let's, as a community, try to push the boundaries of this for Postgres. Thank you very much.